Discord and on Cloud. Okay, so as I said, this is chapter 4, basic estimation techniques. Sonia and Megan are here. Thank you for coming. We're going to go over questions 4, 6, 10, 11, and 12, and then, you know, anything that comes up. But I was showing in question 3 that when you're given a question with a regression output looking like this, you know, when you see observation, there's number of observations. In a cross-sectional data, it could be number of people. In a time series data, it is like literally years, it could be years, it could be days of observation. Inflation in this country measured monthly, it could be monthly, or in stock market, the data comes even like instantly, right? Stock value. So given what's going on with the stock market, I'm not looking at I have Robinhood portfolio. I don't look at it because it's very stressful, constantly changing, heart attack, hopefully not. So R square shows the variation in the dependent variable, you know, irregular A plus BX. This is a general regression equation, right? A plus BX. Go ahead.
I'm sorry to interrupt. You know, I was looking at this. I was thinking that one was like one of the easiest ones on chapter 4. I guess where I'm having trouble is chapter 7. So so Megan, if you had something else you wanted to review, chapter 4, I think I've got most of it down.
You're referring to chapter 7 questions?
Chapter 7.
Okay,
yeah.
let's go there. Good.
Did you have something on chapter 4, Megan?
Not on the questions. I did have a follow-up that I was like wanted confirmation. So on the p-values, for the purposes of this course, I don't need to know how to discover p-values.
No, it
always
would
given.
be thousands of pages of statistical tables.
Yes.
So no, you are given.
Okay.
Also, t-test. T-test is something we do. You know, I'm teaching you how to do it. However, in a quiz, it's not practical or the test to have your t-table go over, but I taught you how to do it, which you should all know. But what I do, which is very easy, if something is statistically significant or not, I look at the p-value. This is less than 1%, therefore it's statistically significant at 1%. This is greater than 1%, but less than 5%, so it's significant at 5% level. Also, for sample sizes greater than 30 or so, actually we say like infinity. In the t-table, you'll see infinity on the last row. So I just have to show this to you. It's just useful. I'm gonna share my slides. It's opening right now. I just want to give you these little tips to help with the life as well.
And if it's statistically significant on 1%, it would also be at 5% and 10%.
Yes,
okay.
Correct. That is correct. So let me do new share. Can you see my PowerPoint slides or no?
Not yet.
Cool. So it's just asking you constantly share. So this is chips. Now you can, right?
Yes.
Cool. So look at t-table. I'm going to pull up. Okay. So in the t-table, right, we have degrees of freedom 1 through 1000. After a while, it's INF. INF here is for infinity. Okay. So anything like after 1000 in our data sets, they're literally like, you know, I have data recently. I used 7,000 observation. I had data with almost 1 million observations. So I don't even look at this table. Do you know what I look at? I'm, by the way, plugging my professional microphone because it's better. Can you hear me better? Hello? Is it better?
Yeah, it sounds good.
Okay, I'm going to put my earbuds on too because obviously microphone comes with strange. Okay. All right, just going back to this. So I only memorize this slide. 0.576. So this is for 1% level. We say about 2 on an average for 5% level and 165 or so. So I have these numbers in my mind, right? Okay, it's greater than 0.57 or something. Okay, this is significant at 1%. So for large samples, that's like it. But what we teach in economics, if it's greater than 2, it's definitely statistically significant, right? 1.96, significant, more than, by 5%. So that's one shortcut we use. But yes, in the test, what should you know, right? Okay, I'm going to share right now. In the test, you will be given, I mean, we're not preparing for test only, for life. When you see a data output, right, p-value, you see it, you are never to calculate any of these, right? T-ratio you can calculate because it's parameter estimate divided by standard error, but it's easy. But T-critical value, you find it from table, that's fine. If this one is greater than that, then you say it's statistically significant. But my easiest way, because I love shortcuts, I see p-values. And you will never calculate those. Yes, I highly recommend using p-values to determine. Okay, so now we're going to go to chapter 7. Okay, I stop sharing. It's again dark. It stopped sharing. And I plan on actually doing these problems. For instance, next week I'll probably post next chapter's problem solutions by Tuesday, so you have time to practice. Yeah. But I also want you to spend some time with it.
Yeah.
Okay, so we're chapter 7. Let's go to question 4. Okay, so let's take a look. I'm going to minimize the videos. If you have any questions, just, verbally let me know. Is that okay?
That's fine.
Okay, let's work on these. A linear industry demand function of the form. Okay, so this is quantity sold or produced, right? Demand function, that's the sold, people's demand. A plus BP, this is the own price. CM, M is the, it says income only, right? But here we're talking about median income. It could be median income within 3-mile radius, so on and so forth. And PR is the price of related goods. This could be substitutes, complements, okay? So according to law of demand, I'm just going to teach you at the same time. B needs to be negative. Why? Own price goes up, quantity demanded goes down. Let me give you an example. Price of gas. Everybody's like, please, not that example. Price of gas, and in Corpus Christi, it's very cheap, but it's 4.10 right now, maybe higher. So I'm actually driving minimum, even, just avoiding. I don't drive as much as I used to drive at $2 gas, right? So price of gasoline goes down, quantity of gasoline sold goes, price of gasoline goes up, quantity of sold goes down. My brain always goes to the next thing. Okay, M. So what about C? If C is positive, this is what we call a normal good. Normal good, which means income goes up, you consume more of it, okay? Movies, everything. If C is negative, this is an inferior good. So imagine things you stop buying when you have more income. Generic toilet paper, okay? How about D? So D is positive. These are then substitutes, because this is price of something related, substitutes, okay? Which means price of related good goes up. For instance, this is Pepsi, right? So this happened to me. I'm a big Diet Coke drinker, diet soda drinker. So price of Diet Coke goes up, and if it's $10 per 12-pack can, I don't care about taste. I'm going to consume more of the other one. So again, price of Pepsi goes up, quantity Coca-Cola sold goes up. And if D is negative, these are complements. Complements are things that go together. So in this case, price related good is, let's say, gasoline price goes up, right? Quantity of SUVs go down. So I am now seeing lots of social media posts by my friends who own American muscle cars, right? So anyways, long story short, somebody who owns a Challenger was complaining. Somebody who has a Corvette, I literally love that car. They were like, it's so expensive. Going back to our class, okay? So after this little bit information, by the way, thank you so much for coming. It's really cool that you guys came, because it's a different kind of understanding, right? When you hear live, and I can see it in your eyes, like, okay, they didn't get this, so I can re-explain. And please interrupt me anytime. Don't feel like, oh my gosh, I didn't get that. Don't be quiet, right? But none of you are quiet. That's good. I like that. You need to, take what you, okay. All right. So I'm going to go over all of it, right? So I'm not going to just be like, oh, okay. This is
well, I just wanted to say, going over this will help me, because I forgot there are 2 number 4s on chapter 7. So there's those initial 1 through.
You didn't warn me. Yes, multiple choice.
I didn't want to stop you, because this is a good foundation to help understand, because it does relate exactly, because they're talking about the complements and substitutes.
Yes. Yes, and this is reteaching, literally. So I'm going to post this online too, on our YouTube channel as well, so people can go and watch it, because some people are working. Okay, let's go back. And I highly recommend, for some people, I like watching things in slow motion if it's something dense, and if you get it easily, right? Or if you don't have patience, depends. You can also watch it at higher speeds sometimes, or past the parts. I don't know. Just okay. Is the sign beta head as would be predicted by theory? Why? Let's take a look. What was beta head? So I'm going to go in here. Intercept, this is A hat. P, B hat, negative. Actually, yeah, it's supposed to be negative. C hat. Ooh, we have an inferior good. And D hat. Oh, these are substitutes. Okay, so look, B hat negative. B hat is negative. Okay, yes. This is what law of demand says. Okay. Does the C imply about the good? Okay, so C hat is negative. Okay. So what happened was incomes went up, quantity went down. So this is like ramen noodle situation, right? I haven't had ramen noodles that, what brand was that? Maruchan or something, since December of 2007. Because I got a real job after that, and I said never again. Okay. So long story short, that's an inferior good. I do this with cereal too. If I'm very financial conservative, but if I feel the pinch, I am like, okay, this month, we're buying generic toilet paper that dissolves in the air. But this is this is if I have income, extra money, I'm going to lower the consumption of this good, right? So you can see my screen, right? You're seeing everything I'm writing.
Yeah.
On question A, whenever it's saying the sign of B hat as would be predicted theoretically, is it saying, does it match the theoretical?
Yes, that's what it means. So theory says, yes, price of the good goes up, gasoline price goes up, quantity gasoline consumed goes down, which is happening right now. I just saw the news article saying that demand for gasoline has not been up as much for summer travels. And, you know, I also cut down on travel. Okay. So sign imply that it's an inferior good. It's an inferior good. For it to be normal, it's supposed to be positive. I have more income. I'm going to go to, for instance, movies more often. Movies are normal good. So let me just tell you, most of the goods are normal goods, and inferiority normalcy depends on the person. For instance, for me, something is normal good. For instance, I like Subway, right? I used to eat a lot, but I mean, I don't eat anymore. It's got nothing to do with income. I used to eat Subway, normal good, more income, I'll eat more often. But let's say LeBron James, maybe he's like, I'm not gonna eat Subway, right? He's like, I have my, the more money he has, maybe he has never even eaten. We don't know. So it depends. Normalcy and inferiority depends on the person and the good. But ramen noodles, definitely inferior. Generic stuff tends to be inferior. So just keep that in mind. Even, for instance, I do that. If I have more income, I feel good about my budget that month. I go ahead and buy, I have allergies, regular Benadryl. If I am on budget, I do buy the generic, but generic, I don't know. I feel like it's not as effective. Anyways, long story short, that's the that's the little, you know, teaching, little bit more deeper. What does the sign of D hat imply about the relationship between commodity and this good? So what, you know, D hat is here. So D hat, right? 126. So D hat being 126.35, and it's positive, right? So that means price of related good goes up, quantity goes up. They have a positive relationship. Positive relationship doesn't mean they always go up together. That means they can also go down together. That means same directional relationship. They move together. So if price of something goes up, immediately think about two examples. For substitutes, I always do Pepsi Cola, Coca-Cola. Okay. For complements, I always do gasoline and trucks, like not very energy efficient, right? SUVs. So price of related good, price of here, Pepsi goes up, quantity of Coca-Cola goes up. So this is a substitute relationship, substitute. Okay. Our parameter estimates statistically significant at 10% level of significance. I am, you know, can you see if they are statistically significant at 10%? 10%.
I guess they would all be, right?
So look, this is, yes, this is 0.01%. Yes. Yes. This is 0.04%. 0.08, less than 1. So these first three are 1% significant. This one is the party messed up the party. But it's okay, because look, it's asking you if it's 10%. Well, this is 8.92%, which is less than 10%. So it's yes, still statistically significant at 10%. Yes. This is the easy way to look. And you can also check the T table. I'm going to show you, because I mean, just for the sake of being complete, okay? My screen is paused right now because I am pulling up my slides.
While you're doing that, I had a question about
Go ahead.
complements and substitute goods. So I think I was doing the technical questions.
Yes.
And one of the questions was talking about the relation between air travel and rental cars. So asking, and it wasn't, there were no equations, no like positive, negative. It was just, what do you think that would be? So I thought that they would be complements, because they would go down together. If you're not taking airplane to go places, you don't need a rental car. And whenever I was looking up solutions, it was saying that they were substitutes because if you're not taking airplanes, you would be doing travel cars or like rental cars. So
That's an example of what I call not a good question. So as a
okay,
professor,
like, that seems like
as
not
a
good question.
professor, I am very careful about, because this is the part of being a professor, right? I sometimes find mistakes on books, in every book, every single book. I find mistakes. Megan, you found a mistake in the solution. Okay. It's
I'm
not
also
very
a
common.
teacher. No, I'm also a
It's
teacher.
It's not very common, but even if it's like having a fly in your coffee, right? Like the fly touched the surface. Let's say it's hydroponic or whatever. I'm not gonna go technical, but like it spoils everything. Well, I'm not gonna let it spoil everything because I choose my questions carefully. And that's not a good question because you can literally think like, I'm a business traveler, I'm gonna fly, land, and I'm gonna need to
Need a car.
get a rental car. Or, right, my flight is canceled. You can get a rental car and drive to the nearest airport. If your home is 4 hours away, you will be driving. So long story short, that's an example of a question I don't, I will not have it. Sonia told me one time, remember, Sonia, you were like, what is this question? And I was like, there will not be a question like that, because that's not a good quality. And books make, I'm just telling you a long story, but that's in my book, it could be both. And it could be not very close substitutes. They're not really close, because flying, how am I going to fly to Bangkok from, Texas?
Right.
How am I going to drive, right? I said fly. My brain is. So that's something I want you to know, folks. If it doesn't make sense, right, I am just not gonna have those kind of questions especially in the exams. I'm very picky. Okay. So don't worry about those.
Very good.
No double answer. Just read questions carefully. So next, did I answer your question?
Yes, definitely. Oh, okay. And on your, I guess it won't matter and like how we're doing, how your exams and quizzes are, but in, I guess, like real life, how often would you need to determine if you're using a two-tail test or a one-tail test?
So one-tail test is to, we don't use it. Okay.
Okay. In the class, or just not typically in real life either?
Yeah, you can use it. You can use a one-tail test. It's literally to test for whether something is positive or negative, positive and statistically significant, or negative and statistically significant. Okay. Or we can even do tests like whether B hat. I keep saying beta hat for bees, so I don't know if you caught up on that. Whether B hat is greater than, let's say, 5, you can test that too. So that's going to be one-tailed. So whenever you test something is greater than or equal to or less than equal to, that's a one-tailed test. But here we just want to make sure it is not 0 statistically. So another way to find, going back to our question, you can see my Word file, right? Another way to find another way to, determine whether they're 10% statistically significant is we're going to grab n, right, minus k. N is 32 here. Boop, number of observations. K is 1, 2, 3, 4 minus k. So degrees of freedom is 28. Okay, we're looking at two-sided test, 10%. So I'm gonna go to my PowerPoint slide, 28 degrees of freedom. Let's see, oops, 28 degrees of freedom. Okay, let's make it small. Oh my gosh. All right, so 10%, 28 degrees of freedom here, two-sided. Okay, so 1.701, that's my critical value. That's my yardstick. I want to be greater than this. 1.701 is T critical value. This screen is a mess. But you can see. So as you can see, all these numbers, all of these, oops. all these numbers, let me just pick a color. So all these numbers are greater than 1.70. Let's pick golden glitter. So all these numbers are greater than 1.701. This barely made it, right?
So we're
there,
still seeing we're still seeing the,
okay.
I want to see the glitter.
Can you see the glitter?
No, because we still see your PowerPoint with the T
Okay.
schedule.
So I'm then going back to the crazy screen because it's gotten a little bit, okay. I then manually have to always change it. So it looks like craziness. So I'm going to delete some stuff. But did you see me deriving this part?
Yes, totally
Okay,
got that.
perfect.
Totally
And
got
then 1.71, this is the glitter gold one. So T ratio, all these exceed this 1 point. So T critical CV critical value is 1.701. All these numbers exceed that value in absolute value. This one barely made it, so it's also statistically significant at 10% level. I just wanted to show you that.
Okay, cool.
Okay, I'm going to clean this because this is madness. So you can watch all these videos later on too. Okay. Using the values. Okay, this is just plugging in the value, but let's do it. Using the values, price $48, income of people $62,000, 450, and price of related good is 250. Calculate the estimate. So price elasticity of demand, income elasticity of demand, cross price elasticity of demand. Okay, so in this case, first of all, price elasticity of demand. Okay, I don't like memorizing stuff because my brain just I don't like it. Price elasticity of demand is basically percent change in quantity, percent change in quantity divided by percent change in price. Okay, so as a response, what's the response in quantity to a price change? 1% price change. How can we write this? So it's going to be change in quantity, right? Final quantity minus initial divided by Q is going to be initial quantity. Change in price divided by initial price. So percent change, I'm just going to, percent change in, let's say your wages, okay? So this happened. Let's say your initial, I'm just giving you literally, I'm not insulting your intelligence. I just like to give example. So let's say initial wage, somebody's getting paid $20, okay? I put W0 for initial 0. And this person recently got a raise, inflation adjustment, okay? Now their salary is $28, which looks great, right? Inflation is like 8%. Let's see if their salary caught up to this. So percent change in wages is going to be final wage, initial wage divided by initial wage. So that's why, right? That's why this guy, the numerator is percent, sorry, not percent, change in wages, final minus initial divided by initial. Okay, so that's what I'm writing when I write that. So if we calculate this, it's going to be, I'm sorry, guys, it's just very small space, but I'll make do. Let's do green. So it's 28 minus 20 divided by 20 times. You can do 100, obviously. 8 divided by 20 times 100. Okay, so this is going to be like 4%, 0 point. I mean, you're going to get 4%. I should be correct. No, 40%. Okay, so is this a good raise? Yes, this is a pretty good, this is a pretty good catch up, right? If the inflation rate is 8%, this is going to help you a lot.
Okay.
And some people don't know how to calculate this percentage. Some people, instead of put initial value, they put the final value. So if you put 28, This is done by a Harvard professor, actually. I don't know if it's a urban econ professor. Urban legend, he was mad that he didn't get a good salary raise because he put his final in the denominator at the bottom. So it shows like a small raise. Okay, so where am I going with this? I'm going to get rid of all this. So when you write down this formula, elasticity formula, you don't need to memorize anything. I personally can't memorize stuff. So I'm going to rearrange this. So it's going to be change in quantity divided by change in price. This goes up to the numerator, price divided by quantity. So it's going to look like elasticity formula is change in quantity divided by change in price times initial price and quantity. Okay, so this guy is always, this guy is this is your B hat. Okay. All right, so this is your B hat. Change in quantity divided by change in price. Okay, so look, change in quantity is a response to change in price, literally the definition of B hat. So I'm going to plug in B hat here. Okay, so what's my B hat? Let's grab it. B hat is here, negative 432.59. Okay, negative 432.59. Did I do it right? I love to, yes. Okay, so this is my B hat. I need to then plug in price and quantity. Price is given, 48. To find quantity, this is what you're going to do. You're going to plug in everything. So you have to find quantity all the time. So this is A hat. I'm going to mark everything. B hat, C hat, just plug in everything. D hat. And then this P is giving us 48. M is giving us 62,450. PR 250. So this is the only tedious part.
Oh.
Okay. Once you get 16,705, you just plug in 16,705. For P, we plug in 48. And that's pretty much it. So once you get that, elasticity is negative 1.21. What does it mean in English? So first of all, is this elastic or inelastic?
Less than 1.
So it's
Greater than 1. So it is inelastic. No,
So it's greater than 1. We call it elastic.
Elastic.
Okay. What does it mean in English? So this number, what's its meaning in English? I am interested in that. That means this number, if you increase, if price goes up by 1%, quantity goes down by 1.25%. That's a lot. So if price goes up by 10% with the same token, 10% increase in price, quantity sold will go down by 12.5%. What if you double the price? If price goes up by double, quantity demand will go down so much, you're actually going to get into huge trouble. So this is elastic demand. That means this good has a lot of substitutes.
okay.
Next one, income elasticity of demand. Okay, this is also not too bad. I do the same thing because I don't like memorizing anything. Income elasticity of demand. Okay, so this is basically income elasticity of demand. How your quantity responds to your income changes. Okay, this is percent change. I apologize. Okay, so then change in quantity divided by quantity, change in income divided by income. So this numerator stays by itself, right? This denominator comes up, but you flip it, M over delta M. Delta is for change. Okay, so this is again delta Q delta M, which is peekaboo. This is simply my C hat times M over Q. C hat M over Q. So the formula, you can also memorize it. It's up to you. I like to drive it because I forget, okay? So the same idea, you got Q, you got your M. So plug in C hat. What was my C hat? C hat was here. Let's clean a little bit. This is my C hat. And the same thing for the cross price elasticity of demand. Cross price elasticity of demand is also, let's see, D hat, the coefficient estimate of the price of the related good times price of related good divided by quantity. Okay, you plug in, you also get your number. Positive cross price elasticity of demand means they are substitutes. Negative income elasticity of demand means that this is an inferior good. Okay, that's it. So Sonia, you asked question but these are great questions for you to practice. So once you can do these, you can do anything, literally. So Sonia asked us about question number 4. Let's get started with this one. And after what we've been through, right? This is going to be a piece of cake, hopefully.
Hopefully.
Yes. This is the, what's that? Go ahead.
I was just going to say, because from the YouTube video where I got off is the negative 1.5, because in number 3 there was the negative 0.65 M, and so anyway, I was trying to cross-relate what I did in problem number 3 to 4, and it just didn't work, and so that's the reason why 4 is.
So
on that.
Yeah, question number 3, inferior normal. When you see this, you're going to focus on the income. So here what happened, people's incomes went up. It has a negative coefficient, that means quantity. This negative 0.65 tells you in English, if income goes up by $1, quantity demanded will go down by 0.65 units.
Okay.
So there is a negative relationship. Does it make sense? So this coefficient in front of it tells you how they are related negatively. I think that's the most important thing students get confused about. So that means if, I'm going to write it down, if income of people goes up by $1, quantity goes down by 65 units. So there's a negative relationship. Oh, okay. So people make more money. They now consume less of this. Therefore, this is a inferior good. And normalcy and inferiority is known through M, people's incomes. Okay. It's an inferior good since M is negative. And this is a trickster. This is PR has got nothing to do. Related good.
Yeah.
It's better, right?
Yeah, because and so that's where I was confused. So in number 4, of course, PR is what we're looking at.
Yeah. Yes. So what do you think is this? PR? So PR, price of related good, let's say went up by $1, right? This tells you quantity of the good in question, consumption went down by 1.5 units. Something else got more expensive. Now people are consuming less of these. So these two goods are related. But this is like a gasoline and let's say SUV relationship, right? So price of related good went up. People are consuming less of the good in question. So these are what we call complements, things that go together. Okay.
When I compare them, I think of like hot dog buns and hot dogs.
Yes.
Like if my hot dog buns price goes up, I'm not having hot dogs for dinner.
Yeah, so let's say hot dog buns are now $20.
Yeah, no, thank you.
You're like, we're not having hot dogs.
Having
This
hot dog.
Memorial Day, we're gonna eat literally like
Anything else?
something. I was gonna find something absurd, like we would need like mac and cheese or something weird. I don't know. Okay, so these are complements because the coefficient of the related good. Is it better now? Is it a little
Yeah,
better?
yeah, that totally makes sense. So, let's see. So when you're dealing with complements and supplements, you're looking at the price of related
Yes.
goods.
Yes.
So that's on the end. So then for A, complement, since the coefficient on M is negative, it doesn't have anything to do with M. So that's why that's not right.
Yes.
Same thing for B, because again, it's poking at M. So really the only two of consideration are C and D. And then so D says substitute since the coefficient on PR is negative. Since we know it's a complement due to the PR going up and the consumption going down, because it says it in the problem, right?
Yes.
So
perfect. Exactly.
Got it
No,
now.
it's look, don't get me wrong. I'm a professor, all these years of experience. I'm going to have a confession. Substitutes, complements really like stress me out. And I just have examples. My brain just works with the Coke, Pepsi because I can relate. And then I do also have complements. I can do gasoline and SUVs or trucks because I can relate. Anyways, long story. I sold a truck 2008. So, and I never got a truck after that. But so it's just like something that, you know, like Megan said, hot dog buns and hot dogs. How are you going to eat hot dogs by themselves or put them in a weird bread? Just not. Anyways, let's go back. For nonlinear demand function in this form, the estimated cross price elasticity of demand. So this is a knowledge. This is a PR, by the way. This is a knowledge question. So when you have this kind of exponential functions, cross price elasticity of demand, right? E hat PR, whatever it's called, is going to be the coefficient of this guy, D. As a matter of fact, the elasticity of demand is going to be this one right here, the power of P, which is B, and income elasticity of demand is going to be this power here, C. Okay. So whenever we have nonlinear demand function looking like this, elasticities are constant numbers and on the powers. And it comes from logarithm transformation.
Okay.
So this is an information. I also derive this, but I not memorize. Like, let's not drive everything. Let's not reinvent the wheel in every question. That's what I do now. So the answer is just look at the power, PR's power, D. If it's an exponential form function. So that's a knowledge, oops, I'm sorry. That's a knowledge question. And here it's PR as well. I mean, some R's don't show up in the text for some reason.
Yeah, I had a lot of issues with the numbers because I copied them over to my spreadsheet and some of them didn't copy over, so I had to go in.
PR sometimes don't copy. Okay. You said, does this make sense? I can drive this to you, but you know, if you're giving something like this, look, Q equals, I'm just gonna throw in weird stuff. X P raised to the power P, not P, P, F, price M raised to the power Y, PR raised to the power K. So here, cross price elasticity of demand would be K. Here, income elasticity of demand would be Y. And here, elasticity of demand would be F. You know, you just look at the powers.
Yeah.
Okay, just general form. I just love to learn the standard and then generalize it so that my brain will pick up next time.
Mhm.
Okay, Sonia, you said number 10.
Yeah.
I feel like they come much easier, right? Once we did that hard one, like long
Yeah.
question.
Yeah.
This is not bad. Okay, the consulting firm estimates the following quarterly sales forecasting model. Okay. So it looks like this. QT is the estimated quarterly data from 2010. This is not, this
Yeah.
year is 2010, 2010. Yeah, please. It can't be like from future to present. 2010 first quarter, 2020 third quarter, and T is from 1 to 43. The variable D is a dummy variable for the second quarter. So in the second quarter, there's something happening, probably seasonally, they're adjusting for that. So the second quarter, maybe, for instance, ice cream consumption goes up during summer. What else? Sunscreen consumption goes up during summer. Beer consumption goes up during summer. What else? Oh, the gym memberships go up first quarter of the year, every year. All those gym tools, everything. So this is what we do. We include a dummy variable, and I explained this question really well, but we include this dummy variable because something's going on in the second quarter that's different from other quarters. So estimates are A hat, okay? This B hat is this. So I don't know why it's called it capital T, but it's really little t. I don't know the inconsistency. And D, dummy, C hat, that's the coefficient estimate. They're all statistically significant at 10%. This is 5%. This is 5%. This is 10% significant. Given the above, these estimates indicates that the second quarter change in sales, okay? So because this is a dummy for second quarter, right? The coefficient of it will give you the change in sales, yes. So it is 2, positive 2. It's 2 units higher than in, 2 units higher in second quarter than in the other 3 quarters. So that's to set the second quarter apart from the other ones.
Okay. Okay, G equals 1 in the second quarter and 0 otherwise. And so the ABC, so I see the correlation now with D. D being the second quarter.
This dummy variables, if you still have questions, for sure, like if you don't understand this is a knowledge issue, for sure look at my videos again. And also I solved this question, but I'm going to solve it again because this is important. So your equation is this, right? But for if quarter is a second quarter, it's going to look different than if it is, I'm going to write quarter equals 1 third quarter or fourth quarter. Okay, so if you're talking about first, third, or the fourth quarter, we are dealing with this equation. I'm going to write it down for you. So for D takes on value 1 in the second quarter, 0 otherwise. That means D takes on a value 0 for the first, second, first, third, and fourth quarters. Okay. So if this is 0, this disappears. Your equation becomes QT equals A plus BT. That's it. For the other third quarter, 3 quarters, first, third, and fourth. If it's the second quarter, your equation is actually a little different. So it's going to look like QT equals A plus BT. Now D takes on a value 1 plus C. So it's going to look like QT equals A plus C plus BT. Interesting. So if I graph this, I think if you're a visual person like me, you'll appreciate this. This is what it's going to look like. Let me find some space. Okay, I have space. So look, I have time here. Okay, I have my sales. I'm trying to predict my sales. Okay, so it looks like this. First quarter, second, did. First quarter, second, did. First quarter, second, boom, boom. First quarter, second quarter, did. So look, I need to fit this one. This is the quarters first, third, and fourth. This guy is a different animal. So the second quarter is marching to its own drum. I think I'm using the wrong term, but it's okay.
No, I understand.
So this is doing its own thing. It's in a different parallel universe or something. So how do we handle that? This is what we are doing by including this dummy variable. This is something you will appreciate it, I think. So this is for quarter. This is for quarter 1, 3, and 4. Okay. So A, slope here is B. Okay. So this equation becomes QT equals A plus BT. Okay.
Okay.
This one marches to its own drum. So its intercept is A plus C, right? Not A anymore. This was A only, intercept. A plus C, slope is the same, BT. Okay, so this is QT equals A plus C, B plus BT. So when you include a dummy, you're setting apart this second quarter, which acts differently. Seasonal adjustment.
Okay.
So long story short, it's asking you, excuse me, second quarter change in sales is the difference. That's C, the dummy coefficient of the dummy variable, C. So C is 2 units, okay? 2 units larger than in the second, than in second quarter than in other quarters.
Okay.
Is it better?
Yeah, that makes better sense. I guess what I was remembering from the YouTube videos is how the D, and it was in several problems with the dummy variables, with the D canceling out and becoming zeros. Then I was like, just trying to draw that correlation with the D being 2 and that being the answer.
So here, dummy never cancels, but for first, third, and fourth quarters, it takes on the value 0. Oh, this is a very strong. This is a very strong color. Takes on value 0. So this is your equation. For the second quarter, this is your equation. And the only difference that sets apart second quarter is the coefficient of the dummy variable, which is 2 units. So it turns out second quarter intercept is 2 units larger. Okay.
Okay.
So that was question 10. Let's take a look at question 11. Okay, so question 11. All right. Okay, so this is asking you. All right, let's read it. The consulting firm estimates the following quarterly sales forecasting model. Okay, same thing. Again, there's one extra 0. Blah, blah, blah. Given the above, what's the estimated intercept of the trend line in the second quarter? So now it's asking us the trend line intercept. We did this already here. So the intercept of the second quarter is A plus C. And I'm going to write this down again. If second quarter, right, then you take your D takes on a value 1. Therefore, QT becomes A plus BT plus CD. D takes on a value 1. So intercept is A plus B. A plus C, I apologize. My eyes went to this B. Plus BT. Okay, so we're looking at A plus C. What's A and C? From the results, A hat is here, C hat is here. I'm going to add them up. 22.5 plus 2, 24.5. Okay.
So then so that one was pretty easy.
Mhm.
But I guess my only question or comment really is just to confirm and perhaps reinforce in the question it asks, what is the estimated intercept
Yes.
of the trend line in the second quarter? So when it asks for the intercept, is that like an indicator that you're going to be adding two together?
No, yes. When it says intercept is here. We are trying to estimate a trend line here, right? Quantity regressed on time. And with the dummy variable, it just changes the intercept for the second quarter. Without dummy variable for quarters 1, 2, 3. Sorry, for quarters 1, 3, 4. I always want to say it differently. It's A only. So what we're doing here is literally we're trying to estimate this trend line, hopefully to see a positive trend line, right? So if B is positive, statistically significant, then my sales are going up. That's great, right? And C being positive means in the second quarter, my sales actually, my sales are always better, 2 units larger than all the other quarters. Okay. So that's it. So we add them up. Adding up comes from the fact that we are in the second quarter, which means the intercept is not only A, but also C is coming up from here. A plus C. Trend is whether there's a positive trend, it's shown by beta hat. And in this case, yeah, beta hat, right? Time trend, you're looking at time trends coefficient estimate. If it's positive, yes, statistically significant at 5% level, great. My sales are going up every quarter 1.86 units. So that's really good. Of course, it depends on what you're selling. If you're selling like let's say you produce boats, ships, or I don't know, something big, you want your sales to go up 2 units almost 2 units every quarter. That's not bad. Does it make sense?
Yes, makes much
Cool. 12. Well, same thing, same future date. Okay. The variable D is a dummy variable for the second quarter. Same thing. Okay. Uh-oh, I tried to save it. Now it's frozen.
Oh.
It'll be okay. Hold on. Let's see. Okay, I closed it. I am going to open it again because Sonia, you asked for question 12 too. And here we go. Let me share.
Oh, there's Kate.
Hi, Kate. Welcome.
Hi, guys.
How are you?
Good. Trying to figure this all out. I wanted to ask, I know you're looking at stuff, but is it possible for like the exam that we can actually have like a formula sheet that you create for us?
No, there's no, you're not gonna have formula sheet.
Is there a way we could consider it? Maybe we did that with an operations management and it really helped. Like the teacher did it. The teacher.
I see. Yeah.
Like,
no, you don't. Not for this class.
Yikes. And then is it possible, like I understand that you started with the video on questions 4 or 5. But what helps me, and I just bought subscription to Chegg, I need to see step by step.
Yeah.
For me to learn, because I don't learn that way. If it's just the answers provided, because then if I create a bad habit, which I noticed with operation management, I could catch it with the step by step instruction. I think Chegg will help as well to supplement.
Hey, I've also been did the check thing as well, and they do go over step by step all of the technical and applied questions at the end of each chapter. And then those directly relate to the practice questions and also the quiz questions. So
Good.
it's really,
Well, I
really
did
great
notice
resource.
one of the check had it wrong for like, what's the degrees of freedom? They did 60 minus 1 when it's 60 minus 2 because that was the parameters. 'Cause I'm- today
So
I'm
I've not,
following
yes, I
chapter
have
4.
seen that as well, but you can comment in there like, you got this question wrong, give them a thumbs down. Oh, I'll tell you I'll fix them.
Yeah. Yeah, no, check's good. I used it in my operations management class too.
So I don't understand. Check is not a product that I use. What's the question here? Is it there already? Check has the solutions to
Oh, no.
our.
So yeah, you have to pay a monthly fee. And what
Okay.
it does is you can put in questions that like we're
Mhm.
looking at, and they'll show you like other students will post, it's supposed to be verified,
Cool.
and they'll show you step by step. So some that helps in addition to how you teach us.
Yeah.
Get like
Almost like a tutor.
yeah, like a tutor.
So yeah, you are free to use those services. I can't, vouch for them. I can't guarantee that they're going to be correct all the time, but sure, I mean, I would use any service that's available. But in the videos I am solving, in the videos I posted, solutions are, if you miss a step, let me know. And today we have been going over a bunch of questions, so I'm going to post this video too. It's going to help a lot because it's a little bit more detailed, and that's a value. So I am going to move on to question 12. This is the last question, Sonia, you asked me, and let's work on that. And my dog is pawing me. No, he's like, mom. Okay, so 2010 first quarter to 2020 third quarter estimated, right? The estimated trend line above. What's the predicted level of sales in 2020 fourth quarter? Okay, so this is not that hard, but this is, I would say, one of the hardest ones. But once you figure it out, it's easy. So it's this data set, right? Labeled starting from 2010 first quarter, first unit, and the third quarter of the 2020 was labeled as the 43rd observation for this variable t. Okay, so then fourth quarter, the next period of 2020 is the 44th observation. So for t, or again here, little t, Tiki, stop it. Little t, big T, these are the same. I don't know why the book and solutions thing is labeling it as such, but it's okay. It doesn't matter. So fourth quarter. So let's write down this equation for the fourth quarter. Any fourth quarter. Okay. So for fourth quarters, this D is going to take on a value 0. Okay. So this is going to be 0.
Okay.
So if you write down this equation, start writing it. QT equals A plus BT. We don't have plus CD because this dummy variable becomes 0 otherwise. If it's the fourth quarter, it's 0. So this is my equation that I am, my word is frozen. Oh my gosh. Okay. I think it's going to hopefully get better. Can you guys see? Okay, it's back. Whew.
Good.
All right, so I am going to just plug in the parameter estimates, right? QT equals, we can put a hat because we're trying to find the estimated trend line. So A hat plus B hat T. Okay, A hat is here, A hat, 22.5 plus, what's B hat? B hat is the coefficient estimate of this trend line, 1.86 times T. So I know that the fourth quarter of 2020 is 44. So I'm going to grab my calculator. Okay, so just plug in that value, 44 times 1.86. Okay, this is 81.84 plus 22.5. Okay. And then you're going to get plus 104 and 34. So this is this one. Okay, so it's not too bad, but what if it said 20? I mean, it's not gonna say, but I like making things hard to give you. What if it said 2021 second quarter? Okay, then it did not, right? But I
You have
want to.
You would then count up.
Yeah.
So that's where I got off on this. I couldn't figure out where you got the 44 from.
44 comes from, 2020 third quarter is 43. Fourth quarter is 44. 2020 first quarter, quarter one is 45. 2021 second quarter is 46. So for you need to count. For T, we are gonna put 46. But not only that, my equation is gonna look little different for the second quarter, right? My equation is going to have plus C because this D takes on a value 1. So C comes up. So your equation will be QT equals A plus C plus BT. Just plug in all these estimated values plus instead of T, we are going to put 46. When I first saw this question, I was like, oh, it's going to be, I have to count carefully to find what T is. So that's the whole trick that we have to do.
Okay.
Is it
Cool.
better, Sonia? Did I
Yeah.
answer all questions?
Yes, I feel more, I'm gonna go over these again, but I feel more confident to take the quiz now.
Cool. So definitely go over them. Try to do them on your own. I will be posting this video. It's like 1 hour, 17 minutes. It's going to be long, but it's going to help lots of people. So it's good. If people watch this, their questions will hopefully disappear. And I will tag the question numbers 4, 6, 10, 11, and 12. And also we went over chapter 4 too. So I think this question helped us a lot.
Yeah, that first one was very foundational.
Yes. Any other questions?